everyone, welcome to our channel Euclid Mathematics. So today I am here with a new topic which is a iterated kernel from the subject of integral equation. This is also one of the important topic. I explained that topic in my previous examples also. So if you wanted to check how iterated kernel is applicable in our integral equations, you can check it into my playlist. So if you have any problems, doubts, you can ask me in the comment section. Okay, so here first iterated kernel is given here, k1 of xt and k of xt. Okay, so we want the iterated kernel. Okay, for finding iterated kernel we use this results. Okay, so k1 of xt is equal to k of xt and k1 of xt is equal to integral limit over t to x k of x z k minus 1 z t dz. Okay, already we learned it into the previous lecture. Okay, so we are going to solve some of the previous year question from the competitive exams. Okay, depend on the iterated kernel topic. Okay, so let's get started our today's lecture with the previous year examples from CSIR net June 2015, which asked for 4.75 marks. That means it is a multiple answer questions. Okay, let's get started our question now. Here, let's read the question. Okay, so question is from June 2015. Example number 21. It is given. Okay, so and question it is for 4.75 marks. Okay, question it is quite easy question. We just have to use the two result to find out the iterated kernel. Okay. Okay, now let's read the question. For the integral equation, y of x is given 1 plus x cube 0 to x k of xt y of t dt. Okay, this is the integral type of equation. Okay, and with the kernel k of xt is given 2 raised to x minus t, so that k of xt is here 2 raised to x minus t, and lambda it is here 1. Okay, and then we have to find out iterated kernel k3 of xt. Okay, that means we have to do 3 operations on our integral equation. Okay, so 3 operations, that means we have to find out k1 of xt, k2 of xt and k3 of xt. So k3 of xt is our required answer. Okay, so let's get started our solution. So by using these two results, k1 of xt and k1 of xt, okay, these two results we get the value for our iterated kernel. Okay, so k1 of xt it represent the value of k of xt. Okay, so k1 of xt is a k of xt. So now our task it is here to find out the value for k2 of xt and k3 of xt. Okay, so k1 of xt it has the value integral over t to x k of xz kn minus 1 zt dz. Okay, now substitute this value k of xz and kn minus 1 over zt dz. Okay, so as I'm having here k1 of xt is a k of xt, and which iterated kernel it is given for us, k of xt is a 2 raised to x minus t. Okay, this is the kernel which given in our example. Okay, so we have the value for k1 of xt. Now we want the value for k2 of xt. Okay, now substitute n is a 2 here in our result. So k2 of xt, which is equal to integral over t to x k of xz into kn minus 1. So 2 minus 1 is 1. So k1 of zt dz. Okay, k of xz into k1 of zt dz. Okay, so k2 of xt is equal to integral limit remains same t to x. Okay, and k of xz. Okay, k of xz, how xz come? So k of xz replace t by z. So k of xz, which is equal to 2 raised to x minus z. Okay, 2 raised to x minus z, t replaced by z only. K of xz is equal to 2 raised to x minus z. Okay, this is the k of xz. Now kn minus 1 over zt. Okay, that means k1 of zt, n which is equal to 2, that means k1 of zt. So k1 of zt replace x by z, 2 raised to z minus t. Okay, 2 raised to z minus t into dz. Okay, so this is the value for k2 of xt. Okay, now let's go for further find out the integral. So we can see it here, integral over dz. Okay, and that means 2 raised to x minus z into 2 raised to z minus t. Try to their base are same, try to add their power. So x minus z plus z minus t, minus z plus z cancel. Okay, so 2 raised to x minus t remains same, and it is constant with respect to dz, integral over dz. So 2 raised to x minus t constant, it is outside of the integral. So integral over t to x dz. Okay, so integral over dz to 2 raised to x minus t remains same. Okay, so integral over dz it will be z and their limit x minus t. Okay, that means their limit x minus t. Okay, so x minus t it is coming here for that integral. So k2 of xt, I got the value for iterated kernel k2 of xt is 2 raised to x minus t into x minus t. Okay, now let's move further as a k3 of xt, that answer we want in our example. Okay, so here k3 of xt which is equal to t to x k of xz, it remains same here. Okay, and kn minus 1 of zt, that means 3 minus 1, that means k2 of zt dz. Okay, so k of xz remains same. Okay, k of xz remain same, which is a 2 raised to x minus z as given in example. Okay, so 2 raised to x minus z, and now it is the time to get the value for k2 of xt. So k2 of xt it is here 2 raised to x minus t into x minus t. Okay, so k2 of xt 2 raised to of x minus t into x minus t. Now let's find out the value for k2 of zt. So replace x by z, 2 raised to z minus t into z minus t. Okay, so 2 raised to z minus t into z minus t dz. Okay, So base are same at their powers, 2 raised to x minus z plus z minus t, okay, and to multiplied by z minus t dz, okay. Cancel the possible term here, plus z minus z cancel, remaining 2 raised to x minus t, which is a constant with respect to integral dz. So take it out here, 2 raised to x minus t, and integral over x to t, z minus t remains same here, dz, okay. So constant as it is here, integrate that term with respect to z, z integration z square by 2, and minus t integration constant with respect to t is a tz, okay, and substitute their limit t to x, okay, t to x. So 2 raised to x minus t, it remains same. Now go for further finding their final values, okay. So here their limit it is given here. Now substitute this limit with respect to x minus this limit with respect to t, okay. So this is the substitution of limit. So after substitution we get the 2 raised to x minus t, that 2 common from here, okay. X square minus 2xt minus t square plus 2t square, okay. These are easy calculations, okay. I hope so you can understand it easily, okay. So these are easy calculations. Now let's move for the further steps. So 2 raised to x minus t upon 2, okay. So this is the x square by 2, 2 common from here, it remains x square. Again 2 multiply 2 divide by 2, so minus 2xt it comes here, 2 again out here, minus t square 2 out here, multiply 2 divide 2, 2t square 2 out here, okay. So we can see here 2 raised to x minus t upon denominator 2. So when that denominator goes to numerator, 2 raised to minus 1 it comes, okay. Okay, so it gets 2 raised to x minus t, and when it goes to the denominator, numerator, it goes to minus 1, okay. This one is minus 1 here, 2 raised to x minus t minus 1, okay, under bracket x square minus 2xt minus t square plus 2t square, okay. So x square minus 2xt minus t square plus 2t square, that means it remains plus t square. So this is the expansion for x minus t bracket square. So I got the k3 of xt, which is a 2 raised to x minus t minus 2, it is not there, it is minus 1, 2 raised to x minus t minus 1 into x minus t bracket square, okay. This is the required kernel which we want, iterated kernel which we want in our example, okay. So you can see it here, my third option it is given, okay. Similar option here in our question paper, 2 raised to x minus t minus 1 into x minus t square, okay. This is the required iterated kernel from our example, okay. I hope so you all have understood this lecture for iterated kernel, and similar lectures I uploaded in my playlist also for iterated kernel and for resolvent kernel. Some of the videos are also there for resolvent kernel, which I use some shortcut trick to find out the resolvent kernel, and the actual method for finding resolvent kernel I also uploaded there, okay. So I hope so you all have understood my today's lecture. If you have any doubt, comment me in the comment section, okay. Thank you everyone, thank you for my today's lecture.